Hello everyone, welcome to the second lab session of CSE 250. In this lab session, we are going to introduce you with the series and parallel circuits. First, we are going to discuss about series circuits. So, here is the series configuration of a simple circuit. In this circuit, we can see the R1, R2 and R3 and the Rn resistance are in series configuration. So how to understand if the resistances are in series? The first property that we can discuss about is that the resistances are connected end to end to form a long chain. But the defining characteristics of a series configuration is that the same current flows through all the elements. This is the most important fact of a series circuit. Here we can see only one path is available for the current to flow. So the same current is flowing through all the resistances. So this is a series circuit. Now we are going to discuss about the resistance, voltage and current in a series configuration. First, the resistance. So the total equivalent resistance of this circuit will be just the summation of all the resistances. So the equivalent resistance is R1 plus R2 plus R3 to Rn. And for the series circuit, the voltage gets divided into the elements. It means here you can see the total voltage is Vs. The Vs voltage gets divided into R1, R2 and all other elements. But in case of current, the current remains same. That is the defining characteristics of the series circuit. So here the same current flows through all the elements in this circuit. Now we are going to construct a series circuit, and in this circuit our voltage source is of 12 volt and we have three resistances, that is 1 kilo ohm, 5.6 kilo ohm and 10 kilo ohm. And you can see there is only one path for current to flow here. So this circuit is a series circuit. To construct this circuit, we are going to use our breadboard. So here it is. And we need a power supply of 12 volt. So we are going to use a voltage adapter, DC adapter for our circuit. And this red wire will be the positive terminal of the source and the black wire is the negative terminal of the source. Okay, and we need three resistors. So here are the three resistors. Let's measure the actual value of the voltage source first. So we are going to use our multimeter and we are going to set it to the voltage mode. And now if we measure the voltage, we are connecting the red probe with the red wire and the black probe with the black wire. We get the voltage of 12.53 volt. So we are going to write it down. So this is the actual value of our voltage source. Now we are going to measure the three resistances. First, we take the 1 kilo ohm resistance and we set the multimeter to measure the resistance. So we get it 0.96 kilo ohm. So we are going to write that value down. For the second resistance, the theoretical value is 5.6 and the actual value is 5.16. So we are going to write this value down. And for the 10 kilo ohm resistor, 9.88 kilo ohm. So R3 is 9.88 kilo ohm. Okay, so we are going to use our breadboard now. Here is our breadboard. Before constructing the circuit, we are going to mark some points here. let's mark this point as A. Okay, so these whole lines are point A because there is no resistance here. These are just wire, and ideally the wire has no resistance. So let's mark this point as B. This is point C, and let's mark this point D. And these whole lines are point D because there are no components here. This is just a wire, and this is just a wire as well. So all these points are D. So now we are going to put our first resistance here. This is the 1 kilo ohm resistance, and we are going to put it in the breadboard. So these vertical lines are internally shorted, so we can consider these vertical holes as point A and these vertical holes as point B. So from point B the resistance R2 goes. So we are going to put the leg of the resistance R2 here. This is the point B hole, and it will end, let's say, here. So this is point C, and from point C the R3 resistance starts. So we are going to put the 10 kilo ohm resistance here, and the other terminal will go here. So these vertical holes are point D. Now we are going to connect our voltage supply to the circuit, and if you look carefully, then you can see the positive terminal goes to point A. So the red terminal goes to this hole, and the black terminal is at point D. So we can connect it here, and our circuit is complete. Okay, so now we are going to measure the voltage across these resistors. So first we are considering the voltage across the R1 resistor. So we can write VR1. To determine the voltage, we are going to use our multimeter and set it to the voltage mode again. Now if we hold these two terminals, we can see the voltage is 0.77 volt. So we are going to write the value here, 0.77 volt. And for VR2, we are going to use our multimeter to the resistance R2, and we get the value as 4.20 volt. So 4.20 volt. And for the R3 resistor, we get the voltage as 7.57 volt. So VR3 is equals 7.57 volt. So now we can determine the values of the current through these resistors, because we know the value of R1 is 0.96 kilo ohm, and according to Ohm's law we can write V is equals IR. So the value of current IR1 is equals VR1 divided by the value of the resistor R1. So by putting these values we get 0.802 milliampere. The unit is milliampere. And similarly for IR2, we know the value of the resistance R2 is 5.16 kilo ohm, and applying Ohm's law as well, we get IR2 is equals VR2 divided by R2, and the value is 0.81 and the unit is milliampere. And similarly for the current IR3, we need the value of the resistance R3, that is 9.88 kilo ohm, and applying Ohm's law we get IR3 is equals 7.57 divided by 9.88 kilo ohm. So we get the value of the current as 0.8 milliamp. So here is the thing, we can see that the voltage across the resistors are different. So we can say the voltage is divided across the resistors. If we add these three values of the voltages, we get the total voltage of the Vs. The total voltage Vs gets divided into the resistors. But the value of the current is almost same. Theoretically it is same, but as we are doing practical, so here are some mismatch because of the measurement limitations, and the IR3 current is also same. So we can decide that in case of series circuit, the current is same through all the resistors, but the voltage gets divided.